Okay, so in this class, we are going to learn transforming a relationship into a linear form. Into a linear form, meaning we are going to convert a non-linear equation into a linear form. Now, when we talk about linear form, we will represent the equation of any curve that is not a that is a non-linear into a linear form, and the general equation of a linear form is always in the form of y equals to mx plus c. Okay, so
Yes, sir.
for example, we for example we have a equation y equals to x squared. Now I know that this right now is not a linear form, right? It's a quadratic curve. If I were to plot the coordinates of x and y, and if on the y-axis I plot y and on the x-axis I plot x, then I'm going to get the coordinates are going to be such that I get this quadratic curve. But when I am going to convert this into a linear form, and you are going to convert this into a linear form in such a way that you are going to make this y capital Y and this x square as capital X, meaning the the graph is going to be plotted against y versus x square. On the x-axis, you are going to take the values of x square instead of x. So if I plot, if this becomes my capital Y and x square becomes my capital X, then you have linearized this equation. And the coefficient of x square over here was 1. That's why the gradient is going to be 1. And the y-intercept is 0. So it should pass the line. There, first of all, there is going to be a line with a gradient 1, and the y-intercept should be 0. So that is the whole concept. Converting a non-linear equation into a linear form by plotting the uh, suitable variables on the y-axis and the x-axis. Now, if this is clear, can I move on?
Yes, sir.
Okay. Now, for example, you have non-linear equations such as exponential equations, y equals to kx to the power of n. And in these kinds of equations, we use log. So if I know that there is a relationship y equals to kx to the power of n, so obviously that this one is a non-linear equation, and I need to linearize it. So if I linearize this non-linear equation, the first step that I will have to do is to apply logs on both sides. Okay, I'll have to apply logs on both sides. So I can apply log to the base 10 that we call LG on both sides. We take log of y equals to log of kx to the power of n. That is the first step. And we are going to recall all the properties of the log. So this property on the right hand side is going to be the product rule. If you remember the product, if we were to ask to expand the log of a product, do you remember we would write like this: log of k plus log of x to the power of n. Can I say that? Is this step clear?
Yes, sir.
Now, what will happen to this power?
Multiply LGX.
Yes, it is going to be multiplied by lgx. And if I just rearrange this, n lgx plus lgk equals to lgy. The only variables were y and x. Y and x. K and n were constant values. So log of that constant value will also be a constant value. Now this is the linear form if This tells me that if I plot LGY against LGX, on my axis, if I plot LGY values against LGX values, then the coordinates that I'm going to get will make a straight line, because this is going to be your capital Y, this is going to be your capital X. The value of n is the coefficient of LGX, which is going to be the gradient, and LGK is going to be the y-intercept. So that is how I will linearize my nonlinear equation. So if LGY versus LGX were plotted, the points would be such that I would be getting a straight line, and the y-intercept is going to be LGK, and the gradient will come out to be the equal to the value of n. Okay, is this making sense?
So I didn't get this part.
Which one?
Just after just plotting the points.
Did you understand that we have? Were you clear when I successfully linearized this equation? Till here, is
Yes.
this okay? Now the idea is that initially, let's say I have random values of x and y. Okay. Now the equation was this. The question said that linearize this. So I did all this working, and I was successfully able to linearize this equation in the form of y equals to mx plus c, which tells me that I have to plot LGY against LGX key values in order to get a straight line. So if I have x and y coordinates, corresponding points, x, y coordinates, what I'll do is I'll make another column for LGX and another column for LGY and find the respective values. So for example, whatever x value is, I'm going to find log of that value. Whatever second x value is, I'm going to find log of that value, and so on. So I have all the LGX values. Then for the y values, whatever y value is, I'm going to find LGY for this, LGY for this. Now these represents coordinates of LGX and LGY. So when on the graph paper you plot these points, you are going to get a straight line. Okay, that's the graphical part. Is this making sense now?
Yes, sir.
Okay. Now without drawing the graph, if I were to ask, if I was if I was given in the question that the when LGY is plotted LG against LGX, the gradient of the graph is 2 and the y-intercept is, let's say, 3.1. Then, and the question says find the value of n and k, which are these. So I know that n represents the gradient, so the value of n would be 2 in this case. And the y-intercept is 3.1. So LGK represents the y-intercept and the value is equal to 3.1. So k value is going to be equal to,
Uh, 3.1 to the power of LG,
it's
or
going to be
3.1 to
10
the power of
raised to the
10.
power of 3.1. It is going to be 10 raised to the power of
Oh,
3. LG is always to the base 10. So 10 raised to the power of 3.1 is going to give me the value of k. And for the value of m, for the value of n is always, n is the gradient in this example. So n is going to be 2. This is how we can find the unknown values. So if there is anything you would like to note down from this slide, you can.
okay. So 1 second, please.
Done.
Yes, sir. Sir, if you're waiting for me, I'm done.
Okay. Yes. Now, even in the questions in which the equations is like this, y equals to k a to the power of x. This time x, the variable, is in terms of power. So if you are asked to linearize this, again you are going to take the help of logs, applying logs on both sides. You can take log to any base, but most popularly you will take a log for which you can use your calculator. Now the previous version of calculator had only LG and LN. Now the latest version calculator FX991EX can take log to any base. So it's gonna be up to you. But I would also advise you to take log to the base 10. It is far more easy to work with this. So taking logs on both sides, this time is going to be LGY. Michelle, how am I going to expand this?
Uh, LGK plus LGA to the power of X.
And then what will happen to this power of x?
It'll multiply LGA.
Right. Then I can just rearrange this. Now LGA is a constant value. Variable is x and variable is y. So LGA times x plus LGK is equals to LGY. This is this can be said as capital Y. LGA will become your gradient. Small x can become your capital X, and LGK can become your y intercept. So in this case, the gradient is going to be equal to LGA. So if I have the value of the gradient somehow in the question, I can just write 10 to the power of that value equals to A. And in this way, I can calculate A. And for LGK, the y-intercept in this case is going to be LGK. And the graph should be plotted. If we want to linearize this, the graph should be plotted. LGY should be plotted against X. Then only I can get a straight line. Get it?
Yes, sir.
Okay. So let's say if the question says convert y equals to a e to the power of bx, where a and b are constant values, and it says that convert this into the form y equals to mx plus c. What should be my first step?
Apply log on both sides.
Which log?
LG.
See, whenever we have exponential equation in terms of e, it is always advisable to take ln, the natural log, not
Okay.
log to the base 10. So in
Yeah.
this example, yeah. So over here, what you are going to do is you are going to take ln on both sides. Then you can linearize it. ln y should be equal to,
ln a plus ln e to the power of bx
what can I do with this bx as a power?
multiplied by ln e.
So ln a plus bx ln e. Bx times ln e. Then what?
Is it just going to be bx?
Which where?
Uh,
What is ln e?
is it 1?
Yes, it is 1. So the
Yeah.
equation turns out to be ln y equals to bx plus ln a, right?
Yeah.
So what's your capital Y and what's your capital X?
Capital Y is the small y, ln y, and then capital X as in the gradient will be b,
Yes. The
and then the
the
y
capital
intercept.
Y is ln y. Okay. The capital
Yeah.
Y is going to be ln y. The small x is going to be capital X, and ln a is going to be the y intercept. ठीक है. Right? Is it okay?
Yes, that's okay.
Acha. The two important things that you should note over here is that the variables capital X and capital Y, ठीक है, in the form of y equals to mx plus c, must contain only the original values of original variables as x and y. These y and x should never contain the constant values a and b. So whenever you are rearranging, you will always rearrange in such a way that the capital Y will only have the variables capital Y and capital X will only have the variables of Y and X. They must not include A and B values over here in the form in for capital Y and capital X. And the second important note over here is that the constant values such as the gradient and the y-intercept must only contain the original unknown constants that are a and b and not the variables. So the value of b must not contain any y value. The gradient value does not contain shouldn't be containing any y value. If there is any y value present, it should be taken either with capital X or capital Y. Okay. So let's
Okay.
see another example. You can copy down the question with me. All right. The variable x and y satisfy the equation y equals to a times e to the power of minus bx square, where a and b are constants. The graph of the ln y against x square is plotted, and it is going to give you a straight line. That line is going to pass through the coordinates of 0.55, comma 0.84 and 1.72, comma 0.26. You need to find the value of a and the value of b in this equation. So in order to solve these questions, you will have to linearize first. You will have to come up with a linearized form.
Yeah, so you apply ln to both sides?
Yes, we are going to apply ln to both. Are you done with copying the question?
Yes, sir.
Okay. So if I apply ln to both sides, this is what I get. Then what can I do?
You do ln a plus ln e to the power minus bx square and multiply b
Right.
minus bx
Then,
square.
so can I leave it till
ln
here?
e will be
Do you
1.
understand that ln is going to be
Yeah.
1? Yes. So ln
Yes.
y is going to be equal to minus bx square plus ln a, right?
Yes.
Now the question says that ln y was plotted against x square. So what's my capital Y and capital S?
Capital Y will be ln y, and then capital X square will be minus bx square.
Capital X should be x square, and the value of
Yeah.
negative b is going to be the gradient, and the value of ln a is going to be the y-intercept. Now, on this graph, which represents a straight line, this value of 0.55 is the value for x square, and 0.84, this is the value for ln y. Same goes for over here. 1.72 is not the value of x, it is the value of x square, because I have plotted x square values on the x-axis. This is 1.72 as x square and 0.26 as ln y. Now, can you suggest me how to find the gradient over here?
So you do y2 minus y1 over x2 minus x1.
Great. So for the gradient, I can just do y2 minus y1 over x2 minus x1, which is going to be 0.26 minus 0.84 over 1.72 minus 0.55, which comes out to be equal to
Minus 0.4957.
minus 0.4957. This
I
is
can say
the gradient. This is the gradient of the straight line. This is not the value of b. So negative b, which was the gradient, is equal to negative 0.4957. Therefore, b is going to be equal to
positive.
0.4957. Yeah, this is going to be our value for the b. And the question says give your answer to two decimal places. So 0.4957 is going to be rounded up to
0.5.
0.50. All right. Then for LNA, what should I do?
I did y equals to mx plus c, and then I made m the gradient, as in
Okay,
minus 0.4957, and then I plugged in y and x from one of the pairs of coordinates.
that's perfectly fine. So y, the gradient comes out to be 0.49, negative
49.
0.4957. Although I have rounded my b value to be zero point 0.5 as the final answer, but for the calculation purpose, I'm always going to take the more accurate value, that is 0.4957. So for x, I can take any coordinate. Let's say I take this. So x value is 0.55 and y value is 0.84. If I solve this, what is the y-intercept coming out?
0.5674.
0. The overall answer for C.
Yeah, so that's what I'm getting.
So if you
Oh,
multiply the,
I
yeah, this should be added over there.
yeah, that's what I did wrong.
I'm getting 1.1126.
Yeah.
So this is the value of C, which was equal to ln A. And the question says find the value of ln A. So what is A going to be equal to?
10 to the power of
No,
1.1127.
no, 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 no.
Um,
This is ln, and ln is always to the base. Ln is always to the base E. So this should be
yeah.
E raised to the power of 1.1126. Which
Okay.
comes out to be equal to
3.04.
3.04 in two decimal places. That's correct. Do you have a graph paper with you right now?
So I don't.
You don't. Oh, okay. Okay. So the next question is a graph related activity. You can watch me doing it, and then you can, if you want, you can watch the recording later and do it. So
Okay.
the question is x values, y values. This technique is very helpful in if some experiment is done and you collect the data and the data is not a linear form, it is a curve, it is some curve representing, so you can linearize it to find the unknown values. That's why linear converting from a non-linear to linear form is helpful. So the question is that the table shows experimental values of the two variables of x and y. Part A, by plotting a suitable straight line, show that x and y are related by the equation y equals to k times x to the power of n, where k and n are constants. And the second part is going to say use your graph to estimate the value of k and the value of n. Okay, so What I'm going to do first is I'm going to use this equation over here. The equation is y equals to kx to the power of n. Now it's an exponential equation. Okay, it's up to you. Either you want to take LG, ln, whatever. I can take ln in over here as well. So this is going to be ln y equals to ln k plus n ln x. Now I cannot write ln x as 1. You know why? Because ln e was 1, ln x is not 1. X is a variable over here. Ln y is going to be n ln x plus ln k. Now you know this, that if you compare this equation with y equals to m capital X plus c, the graph should be plotted of for ln y against ln x, and the gradient is going to be n, and the y-intercept is going to be ln k, right?
Yeah, so.
So in order to plot the straight line, I will have to convert these values into these ln y and ln x. So I'm going to draw my table now, and I want you to calculate these values for me. Ln x and ln y. Take out your calculator. Give me the value of ln 5. What is ln 5 equal to?
1.6094.
1 point.
6094.
So that is going to be 6 1. I'm going to take it till two decimal places so that I can easily
Okay.
plot this. Ln 10,
Uh, 2.31.
ln 20,
Uh, 2.995. So
so
3.
3.0, yes. And ln 3 point, ln 40,
3.689.
so 6 9. Ln 80,
4.38.
4.38. Now for the y values, ln of 2593,
7.86.
7.86.
7.38.
Okay,
6.89.
6.89,
6.41.
6.41,
And 5.92.
5.92. Right. Okay. So I can see that on the x-axis I'll have to plot. There aren't any negative values, so this is fine. This is ln y. This becomes ln x. Now, as according to my graph paper, I can take a suitable scale for myself. I just need to go as high as 5 units for the x values. So if I take this as 1, 2, 3, 4, 5, that is going to be enough. And for the y values, I can just go to 8, 9, or 10, right?
Yeah, sir.
Okay. So I can take this as, if I take this as 2, 4, 6, 8, 10. Let's mark the points. 1.61, comma 7.86. So 1.61 can be rounded up to 1.6, and 7.86 on the y-axis. One small box represents zero point 0.2 units. So 7.86 can be rounded up to 7.9, which is somewhere in over here. That's my first point. Then 2.3 comma 7.38, 2.3 comma 7.38. So 7.38 is going to be somewhere over here between 7.3 and 7.4. Then 3.0 and 6.89. 6.89 means 6.9 somewhere here. 3.69 comma 6.41. 3.69 means 3.7. 3.7 comma 6.41. 6.4. 4.38 comma 5.92. 4.38, somewhere between 4.3 and 4.4, and 5.92. 5.92 will be over here. Now I'll have to draw a straight line that connects these points. And since I want to find the y-intercept as well, so I'm going to extend it to the y-intercept. So if this is correct, then yeah, this is a straight line. I've drawn this. Now, the purpose to draw this was to do the next question that says use your graph to estimate the value of k and the value of n. For the value of n, I need to find the gradient from my graph, and for finding the value of k, I need to find the y-intercept from my graph. Do you understand this?
Yes, sir.
So I am going to take any two values on the graph. So if I just take the first and the last value, these values, let's find the gradient. The gradient is going to be 5.92 minus 7.86 upon 4.38 minus 1.61. So roughly, what is the gradient coming out?
1 second, sir. I'm getting minus 0.7004.
Minus 0.7.
Yeah.
minus 0.704. Okay, so
Zero zero
two decimal
four.
places, yeah, 004. Okay, so two significant figures,
0.7.
then n value is going to be minus 0.70. This is my n value, okay? And for the y-intercept, what can I do? Y-intercept is roughly equal to 9.
Yeah.
Y-intercept is roughly equal to 9, and when I linearize this, y-intercept was equal to ln k. So ln k is equal to 9, then k is going to be equal to
E to the power 9.
e to the power of 9, which is,
8103.1.
so in two significant figures, it is going to be 8100. Is it clear?
Yes, sir.
Okay, let's do some practice questions then. So I'm going to write down the question briefly. It says that the equation of the curve is y equals to kx to the power of m, where k and m are the constants. The graph of ln y and ln x is a straight line and is passing through these 2 points, 0, 2 and 6, 10.2, as shown in the diagram. You need to find the values of k and m correct to two decimal places. Okay. This question is from the past paper, June 21, question 3. All right. So you can try this out and get me the values of k and m. This question will not require you to plot the graph, so easily by calculation you can have the values. Okay.
Okay. So I think I have the answers.
What are your answers?
For K, I'm getting 7.4, and for M, I'm getting 1.4.
That's correct. That's correct. But the question said give your answer to two decimal places. So two decimal places is going to be K as 7.39 and
7.39?
M 1.37.
1.37.
Yeah. Okay. Let me give you some other question. Okay. Now just a revision for this chapter. Some review questions. We are done with this log chapter now. This was the last one. So just a review question. Given that ln p is equals to 2 ln q minus ln 3 plus q, and that q is greater than 0, express p in terms of q not involving log. It's a 3 mark question. Try करो आप.
Sir, is it P equals to Q minus 3?
E is equals to
Q minus 3?
nine. No.
Oh, okay.
Try something else.
Q equals to P plus 3?
Uh, See, this is this is how you should be dealing with it. Just a second. First of all, you are going to write ln q square. The number 2 is going to go up and multiply, will be raised as power of q. So ln p is going to be ln q square minus ln 3 plus q. If you remember quotient rule, division rules, ln q square upon 3 plus q हो जाएगा. So ln of this is equals to ln of this. That means, therefore, p must be equal to q square upon 3 plus q. Make sense?
Yes, sir.
Okay. Use logs to solve the equation 5 to the power of x plus 3 equals to 7 to the power of x minus 1, giving your answer to three significant figures. Okay, giving your answer to three significant figures. So that's an exponential equation, and you will have to use logs to solve this. So try it out. This is also a past paper question. It's a 4 marks.
So I'm getting two answers and both of them are negative. I think I've done it wrong.
What was your first step?
I applied LG to both sides.
Okay. So LG 5 to the power of x plus 3 equals to LG 7 to the power of x minus 1. X plus 3 times LG 5 equals to x minus 1 times LG 7. X times LG 5 plus 3 times LG 5 equals to x times LG 7 minus 1 times LG 7. Collect x terms together. So x LG5 minus x LG7 equals to minus 3 LG5 minus LG7. If I take x common, I'm going to get LG5 minus LG7, which is going to go over there and divide. So the answer should be minus 3 Lg5 minus Lg7 over Lg5 minus Lg7. If I want to simplify this further, I can, but the question is not basically about simplification, it's just to give your answer to three significant figures. So you can write this value directly in the calculator and get the right answer.
Okay, so it is. I'm getting 0.95 to two decimal places.
Okay, let me calculate as well. Minus 3 times Lg5
Oh, I'll be. I think
minus
it'll be negative.
Lg7 divided by. I'm getting 20.1. Just make sure that you have put the brackets correct.
Yeah, so I think I did the brackets wrong, and then I also forgot to do minus 3 LG. I just did positive 3 LG.
Okay, no worries. Done?
Yes, sir.
Okay, I'm gonna give you one question right now to try from home, and then, if possible, I'll make a worksheet on this chapter and give it to you. Okay? Given that y equals to 2 raised to the power of x, show that equation 2 raised to the power of x plus 3 times 2 raised to the power of minus x is equal to 4 can be written in the form y squared minus 4y plus 3 equals to 0. So you need to show this. This is part A for you. And part B says, hence solve the equation 2x plus 3 times 2 raised to the power of minus x equals to 4, giving the values of x correct to three significant figures where appropriate. Okay, that is a question. The first part is of 3 marks, and the second part is also of the 3 marks. And so the answer for the second part is 0 and 1.58. Okay. In the first part, you just need to show, and for the second part, the answer is 0 and 1.58. So I want you to try out
Okay.
this question as a homework. Got it?
Okay, sir. Yeah.
All right. So I'll see you tomorrow, inshallah. Meanwhile,
Okay.
if I get time, I'll make a worksheet for you, which you can do till next week. And in the next class, I most probably will start a new chapter. Okay?
Okay. Thank you.
You're welcome. Allah Hafiz. Bye.
Love this.